Okay, so let's discuss a question from heat transfer. This is question on radiation, shape factors, or basically view factors. So there are three surfaces, basically two plane surfaces, the top and the bottom portion of cylindrical, and three is basically your lateral surfaces. So what is asked is the view factor of the cylindrical surface with respect to the base surface. So F31 is what is asked, right? This is what is asked, the view factor. So what is view factor? The view factor is the fraction of radiation, the fraction of the total radiation that is emitted by this surface, how much of that reaches the base surface. So that fraction is basically view factor. So what we will do here is we need to first, F31 is something which we need to get. For each of the surfaces, the summation law, there are two effective laws which you can apply, effective theorems I would say, summation rules I would say, summation rule as well as reciprocity rule. Okay, so now because F31 is, now between 3 and 1 we can apply reciprocity rule. So first apply reciprocity rule between 1 and 3. Between 1 and 3. What does that mean? A1 F1 3 is equal to A3 F31. So areas is something which we know, or which we can get. So F13 something if we can get, then F31 we can easily get it. So the summation rule, now remember that summation rule you cannot apply for 3. I mean you can apply, but the thing is that there will be many unknowns. So we are applying summation rule for surface 1 or the base surface. So F11 plus F12 plus F13 is equal to 1. Now the same summation rule if you apply for 3, what will happen is F31 plus F32 plus F33. Remember that this so what it means is that the total you are adding the fractions, I mean the heat that is emitted by 1, how much of that is falling on 1, 2 and 3, that you are summing up to 1. So this summation rule holds for any surface. Now the question might be, why don't we apply directly for 3 and then get F31? Now when we apply for 3, let's say F31 and F32 are same because of the symmetry, but F33 is something which we don't know and it will be difficult to compute because some radiation that leaves surface 3 will fall on 3 also. So this is we don't know and it will be difficult to get it. So what we do is we do it in an indirect way. We first apply for 1, and why it is advantageous to apply for 1 is for the plane surfaces, the radiation that is falling back emitted by the surface 1 and falling back will be 0. So for the plane surfaces F11, so the self view factor will be always 0. So that is the advantage of applying summation rule. So always the trick is here is whenever you have a plane surfaces, apply the summation rule and then by means of a reciprocity rule get the shape factors or the view factors associated with the curved surfaces. So we follow the same trick. F11 is 0. F12 is given as 0.16 and F13 we get it. So 0 plus 0.16 plus F13 is equal to 1. So F13 would be 1 minus 0.64, that is 0.84. So we know F13, okay, and so F31 by reciprocity rule will be A1 by A2 into F13. So what is A1? A1 is the flat surfaces, area of surfaces of 1, that is pi by 4 d square, whereas A2 is the lateral surfaces, that is nothing but the perimeter into length, so pi d. So remember that this is pi d, the perimeter into the length L, okay, into F13. So this we can get d will get cancelled, d by 4L into F13. Now remember that d is 2R and L is also given as 2R here. So d and L basically are same, so they get cancelled, 2R and 2R. So it is basically F13 by 4. F13 is 0.84 by 4. So that will be 0.21. So the answer f31 is something which we want the view factor of 3 with respect to 1. So the answer is 0.21. Thank you.